we're nearing the home stretch of our quest to find the inverse of this 3 by 3 matrix here. And the next thing that we can do is find the determinant of it, which we already have a good bit of practice doing. So the determinant of C of our matrix, I'll do that same color, C, there's several ways that you could do it. You could say, you could use the idea that it's equal to, you could take this top row of the matrix and take the value of each of those terms times the cofactor, times the corresponding cofactor, and take the sum there. That's one technique. Or you could do the technique where you rewrite these first two columns, and then you take the product of the diagonals and of the top to left diagonals, sum those up, and then subtract out the top right to the bottom left. I'll do the second one just so that you can see that you get the same result. So let's see, the determinant is going to be equal to, I'll rewrite all of these things. So -1, -2, 2, 2, 1, 1, 3, 4, 5. And let me now, just to make it a little bit simpler, rewrite these first two columns. So -1, -2, 2, 1, 3, 4. So the determinant is going to be equal to, so let me write this down. So you have -1 times 1 times 5. Well, that's just going to be -5, taking that product. Then you have -2 times 1 times 3. Well, that's -6. So we'll have -6, or you can say plus -6 there. And then you have 2 times 2 times 4. Well, that's just 4 times 4, which is just 16. So we have plus 16. And then we do the top right to the bottom left. So you have -2 times 2 times 5. Well, that's -4 times 5. So that is -20. But we're going to subtract -20. So it's -4 times 5, -20. But we're going to subtract -20. Obviously, that's going to turn into adding positive 20. Then you have -1 times 1 times 4, which is -4. But we're going to subtract these products. So we're going to subtract -4. And then you have 2 times 1 times 3, which is 6. But we have to subtract it. So we have subtracting 6. And so this simplifies to -5 minus 6 is -11. -11 plus 16 gets us to +5. So all of this simplifies to +5. And then we have plus 20 plus 4. Actually, let me do that green color so we don't get confused. So we have plus 20 plus 4 minus 6. So what does this get us? 5 plus 20 is 25. Plus 4 is 29. Minus 6, 29 minus 6 gets us to 23. So our determinant right over here is equal to 23. 23. So now we are really in the home stretch. The inverse of this matrix is going to be 1 over our determinant times the transpose of this cofactor matrix. And the transpose of the cofactor matrix is called the adjugate. So let's do that. So let's write the adjugate here. So C inverse, this is a drum roll. We're really in the home stretch. C inverse is equal to 1 over the determinant. So it's equal to 1 over 23 times the adjugate of C. And so this is going to be equal to 1 over 23 times the transpose of our cofactor matrix. So we have our cofactor matrix right over here. So each row now becomes a column. So this row now becomes a column. So it becomes 1, -7, 5 becomes the first column. The second row becomes the second column. 18, -11, -2. And then finally, the third row becomes the third column. You have -4, 5, and 3. And now we just have to multiply, or we could say divide each of these by 23, and we are there. So this is going to be equal to, this is the inverse of our original matrix C, home stretch. 1 divided by 23 is just 1/23. Then you have 18/23. Actually, let me give myself a little bit more real estate to do this in. Give myself a little bit more real estate. So there we go. So 1 divided by 23, 1/23. 18 20ths. Negative 4 20ths. Negative 7 20ths. Negative 11 20ths. 5 20ths. 5 20ths. Negative 2 20ths. And then finally, assuming we haven't made any careless mistakes, which would shock me if we haven't, we get to 3 20ths. And we are done. We have successfully inverted a 3 by 3 matrix. Once again, something I strongly believe better done by a computer, and probably should not be part of a typical Algebra 2 curriculum because it tends to be displayed in a kind of non-contextual way.